My name is Stefan Gillium. I'm head of the research group Sustainable Resource Use, which is located at the Institute for Ecological Economics at the Vienna University of Economics and Business. And in my talk, I will present some selected results of our current research, ongoing in the area of global resource use and resource efficiency. And I will also reflect on the results in the context of the current debate towards a green economy. So the title of my talk and what you can expect in the next 30 minutes is Global Natural Resource Use and Resource Efficiency. And I want to address the question, is the world, is Europe, are other countries actually heading towards achieving a green economy? My talk will be structured into 4 parts. I want to start with a quick review of the discussion why resource use and resource efficiency issues have so much increased in importance in international policy agendas, in particular in the context of the debate of a transformation towards what is called green economy. The second part introduces and discusses some of the methodologies we are applying, in particular material flow analysis, which some of you might be familiar with, and I want to provide some more details on this in the second part. The third part will be presenting some empirical trends from the assessments we are doing, in particular on the international and even global level. And then finally, I end up with some conclusions concerning the debate. Are we heading into the right direction, into a sustainable direction? So resource use and the green economy debate have been closely interlinked in the past few years. On the one hand, because of environmental reasons. Many environmental issues are directly or indirectly related to our natural resource use. For example, the issue of climate change, probably the most widely debated and heavily debated environmental issue currently. There are clear links between our natural resource use and climate change, for example, through the combustion of fossil fuels, but also through emissions from agriculture, for example. But also other issues, and this has also been mentioned by the first speaker already, issues related to how our exploitation of mineral resources and our harvest of biotic resources changes land use and landscapes. What's the impact on biodiversity? And in many cases, we face negative impacts due to our extraction activities. So there's a clear link and a push from the environmental side why resource use and resource efficiency issues have so much come to the focus in the past few years. But I would say even more importantly, economic issues have had an impact on the discussion on resource efficiency. And I just want to focus on 2 issues. One is the issue of import dependence. So regions like Europe are very scarce with regard to some of the resources, in particular metal ores and fossil fuels. So here you see a chart showing the import share in the total EU consumption of some of the metal ores. And you see basically regarding many metal ores, Europe needs to import everything. All European industry need to produce its products and export them maybe back to the rest of the world are coming from other world regions. And even some of the major industrial bones, I would say, like iron ore, Europe has an import dependency of almost 90%, copper, etc. So even the bulk metals, we need to import a lot. And this has risen and driven the discussion of how can Europe, for example, ensure a stable access to these resources which are generated and coming from other world regions. Another issue, and this has also been mentioned by the first speaker already, are price developments. So in general, we can see that prices fluctuate increasingly. So this makes planning of the costs related, for example, to imports on the national level, but also on the industry level, increasingly difficult. And secondly, we see a generally upward trend of prices since the turn of the millennium. The prices went down recently a bit, but many experts expect that the prices will keep on a level which is basically below the level which we've seen in the 1980s and 1990s. So against this background, several of these green development concepts have been presented in the past few years. Just to mention, UNEP, the UN Environmental Programme, has launched the green economy concept. OECD has launched the green growth concept. The UN Industrial Development Organization, just located here next door, pushes the green industry concept. And even the European framework development concept of the Europe 2020 strategy pushes resource efficiency and has issued what is called a flagship for resource efficiency, putting this topic as one of the major issues for European development in the next 5 to 10 years. So what does resource efficiency mean? Resource efficiency aims at achieving higher economic value, higher economic output per unit of natural resource use. And this is supposed to have or to lead to a win-win situation, generating both economic benefits and environmental benefits. Economic benefits stemming from decreasing costs for companies. So if companies manage to produce their output with less material, with less energy, with less water input, then costs of production are decreased. And this can eventually have a positive impact on competitiveness. And this competitiveness issue is one of the major drivers also in the European debate. But of course, if we manage to use resources more efficiently, we might also decrease our import dependence, so reduce the amounts of materials we need to import from other world regions. And eventually, we can develop new products and new markets for green, dematerialized, resource-efficient products. So there are clear assumed economic benefits stemming from such a transformation towards higher resource efficiency. But of course, as mentioned before, environmental benefits are also an increasing driver for this. So what is assumed is that higher resource efficiency enables us to kind of decouple economic growth from natural resource and environmental impacts, enable us to keep on growing while actually reducing eventually the pressures on the natural environment. And I will discuss this, whether this is actually achieved with some of the data just showing in the next sections. So against this background, several methodologies have been developed in the past, I would say, 10 to 15 years, how natural resource use can be measured. There are accounting frameworks being developed with regard to several categories: water accounting, land use accounting, of course, greenhouse gas accounting, which is in the core of the Kyoto Protocol and climate policies. But regarding material flows, the concept of material flow analysis has been developed and is now the concept with the highest importance, both in research, statistics, and in policy use. So if we think about how we can measure the physical metabolism of societies, we can see that, of course, we need to tackle the inputs and measure how our resources being extracted, where they come from. Biotic resources, for example, mines have already been presented, fossil fuel extraction, etc. Then many of these resources are actually going into what is called the physical stocks, so metal, mineral resources being parked within the economic system as part, for example, of our transport infrastructure system, of our buildings, or as part of durable goods, cars, computers, etc. So this part of stocks within the economy is rapidly growing and has been rapidly growing in the past decades. And of course, after a shorter or a longer time period, products and materials are removed back to nature. So we have air emission outputs, wastewater, waste generation, etc. So all these three pillars are important in order to gain an overview of what is the overall metabolism of society, what's the overall interaction of our economy with the natural systems. Some more background on the methodology of material flow analysis. So this is a method which enables us to calculate what's the material use and the material efficiency or resource efficiency on different levels of activity. So we can perform material flow analysis for a product or a service, or if we step up higher in levels, an economic sector like the chemical industry or the car manufacturing industry, and finally, even of countries, or on the global level, as I will show just in a minute. The unit of measurement is tons, mass units. So we actually, we transform all types of materials into mass units, and many primary statistics like metal ores and mineral statistics, they are in weight and mass units. One important issue is that material flow analysis has been standardized on the international level in the past few years. The European Statistical Office, Eurostat, played a key role here in pushing also on the global level the harmonization of these methods, and the OECD endorsed also this approach. So if material flow accounts are produced in various parts of the world, they are more or less currently already based on the same methodology, which is very important in order to ensure comparability between the results. In the European case, data for all European countries are available through the European Statistical Office. And actually, since 2011, all member states of the EU are obliged to collect and send data on material flows to Eurostat. And if we look on the global level, there are several global databases that have been developed in the past few years. And currently, for example, the UN Environmental Programme under the umbrella of the International Resource Panel is aiming to bring together the different groups which have been working in the past few years on generating such global data sets. And we are one of these groups involved in this UNEP initiative. When working with the issue and the method of material flow analysis, I often face the critique of people saying, how can you measure everything in tons if different materials have so different environmental impacts? How can you compare 1 kilo of sand with 1 kilo of plutonium, knowing that the environmental impact will be completely different? My answer is, first, this holds definitely true on the micro level. So if you compare 1 ton of sand with 1 ton of plutonium, of course, it's very different. But the issue is that on the society level, societies don't function only on sand or plutonium. So societies and economies function on a very specific mix of materials, as we will see later, consisting of biomass, biotic resources, fossil energy resources, metal ores, and other minerals. And it's actually very different to change this mix of materials that is being used by our economies. And if we go through each of the main material categories we consider in material flow accounts, we actually can establish clear and direct links to many environmental impacts. For example, the biomass harvest, so biotic resources from agricultural production or from forestry. Of course, we have clear links to issues related to land use, sometimes land use changes, destruction of rainforests, for example. We have clear links to issues of water and water scarcity. The agricultural sector by far is the biggest consumer of water. And of course, we have issues related to pollution, groundwater pollution, etc. So these are just a few of the issues related to biomass extraction. If we look at fossil fuels, of course, there are many environmental impacts related to our use of fossil fuels, starting with environmental impacts that might be generated at the extraction site, but more notably, of course, related to energy production and greenhouse gas emissions, the use of fossil energy to maintain our everyday transport and transport system. So there are clear links also with regard to this material category. If we look to minerals resources, again, some of the issues that link mass and volumes of materials to environmental impacts. For example, cement production, a very CO2 intensive process, so contributing to climate change. We have the destruction of ecosystem, the cutting of landscapes with impacts on biodiversity, etc. All these are related to our use of mineral resources. Finally, metal ores. We've already heard in the first presentation, metal ores are, as in the crude ore, often occurring in very low concentrations, so very water and energy intensive processes have to be implemented in order to concentrate the metals. We have wastewater issues related to this, and of course the question of where the products that contain the metals are actually ending up. So this picture aims to provide an overview and make the point that each category of materials we are accounting for clearly has environmental impacts of various dimensions. Finally, I want to emphasize that our group has, since more than 10 years, developed the largest international database on material flows. And if you visit the website materialflows.net, you can actually download a lot of data with data for a time series from 1980 to now 2011 for all countries worldwide, for all resources. You can visualize the results, creating your own world maps, etc. We have download packages where you can download PowerPoint slides with key graphs, etc. So yeah, you might be interested to have a look at it, and maybe it could also be useful for your teaching activities. Okay, so let's come to some of the empirical trends and discuss some of the developments we see from the data. Here we see the global material base, or the material basis of the global economy, so the annual extraction of various types of natural resources from 1980 to 2011. You clearly see that the overall level of natural resource use has steadily increased over the past 30 years. So starting at around 35 billion tons of resources being extracted in the year 1980, we are now already somewhere beyond 80 billion tons. So more than doubling of our physical metabolism just in 30 years. You see that the economic crisis led to some deceleration of the growth, but actually in 2011, and then we are currently working on the 2012 data, you see that the growth has actually picked up again. It's also interesting that looking at this period, we can specify two periods of time. We have a period from 1980 to around 2000, 2002 with lower growth rate, and then clearly from 2003 onwards, the global material consumption has accelerated, which is particularly due to the rise of emerging economies like China, Brazil, India, who around the year 2000 really picked up economic growth and starting to have two-digit levels of economic growth. And this clearly had an impact on the overall development of global material consumption. If we look at the different material categories, we actually see that the non-renewable resources, metal ores and in particular mineral ores, they showed the highest growth rate. So minerals in particular for construction purposes, they showed a growth rate of more than 200% in the last 30 years. Also, today we use more than 150% more metal ores than just in the 1980s. Whereas in the biotic part, there was a growth observed, but not as strong as in the non-renewable area. If we look at some of the resources of the single commodities, and material flow analysis always starts at the level of single commodities. So we start really with counting on the biotic side wheat and carrots and timber, as we do account for each of the metal ores and each of the industrial minerals, for example. And we basically see we use today more of each single material. The growth rates has been different across the different materials. But basically, if we look, here is 1980, here is 2011. So we see upward trends basically for all materials. And here I put it on another slide because it would have just exploded the slide. The consumption, extraction and consumption of construction materials in particular increased. So from around 10 billion tons being used in the year 1980 to we are currently likely around 35 billion tons being used in the construction sector already. Globalization and international trade also led to a situation where increasingly volumes of raw materials and products are transported by ships and planes, etc., on the global level. So here we see the development of the physical trade. Normally trade is analyzed in monetary terms, but we are interested in the physical picture, so 1980 to 2008, and also here we see a continued increase of the levels of products and raw materials being traded around the globe. So more than 10 billion tons of various products are currently being traded, with fossil fuels, in particular oil, being still the major traded commodity on world The material flow accounts we develop, they start on the national level. They start on the commodity level on the one hand, but also on the national level on the other hand. So we can aggregate country groups in order to determine which countries actually contribute which share to the overall growth. And basically I want to highlight here one issue, the group called, we called here the BRICS plus countries, which is China, India, and around 10 countries, emerging economies as they are called. They significantly increased their share in global resource use in absolute terms, while other regions maintain more or less stable, or even, here we see the OECD countries even show a slight decline, but this decline might also be due to the economic crisis with generated 2008 and 2009, some declined. So there is the BRICS countries in absolute terms contributing an increasing share. If we look at the per capita consumption levels, the situation and the story is very different. First, we see that OECD countries still have by far the highest levels of per capita consumption. Somewhere between 15 and 20 tons per capita of resources are being used there. While, for example, the least developed countries here, they consume 5 tons, or the poorest countries even down to 2 tons, which definitely is a problem in terms of inequality and social sustainability in the global context. We also see here the steep rise of the BRICS countries in the per capita consumption levels, in particular around the year 2000, 2003, this curve picked up. A different view to look at the same story, basically. You might know these world maps, these rescaled world maps being produced by the World Mapper Group, and we sent them our data and asked them to produce such a graph for us in terms of material consumption. And here you see basically the same story. China, for example, in the year 2008 contributed 28% to the global material consumption of natural resources. And this is up from a contribution of only 8% in 1980. So this shows that some of the emerging economies really gained in importance, not only in economic terms. We see this in increasing shares of GDP of these countries to global economic growth, but also in physical terms. India, for example, raising its share from 4% in 1980 to 7% in 2008. While on the other hand, for example, the US had a share of 19% still in 1980, declining to 13% in 2008. So here the shifts, the economic shifts in the global economy are accompanied by shifts in the physical consumption in the world economy. And here a more detailed look, I've already talked about the Chinese case, so we try to understand a little bit better what's actually driving the growth of consumption of material resources in China. And here we made a calculation, this is still data from 2007, but basically it says which economic activity finally drives the natural resource use being consumed in China. And actually we found that only a bit more than 20% is actually related to household consumption, so real consumption as we know it, and more than 60% is actually related to investments, in particular in the construction sector. So you can conclude that the building up of infrastructure in China, the expansion of cities, the building of the energy system, like China opening 2 coal-fired power plants every week, the building up of transport system, airports, trains, etc. This is really driving the material consumption in China, and I assume also in other emerging economies, while the actual consumption level, my private consumption, so to say, is still at the level of 2 tons only. So quite below the consumption level that actually we face and we have in the OECD countries. 11% finally is contributed by other investment, manufacturing, in particular machinery, for example, as Chinese is one of the main producers of exported goods in the global economy. A lot of investments are also located here. But the conclusion is really the construction and infrastructure is a key area and drives to a large extent the dynamics in resource use. And going even one step further up in terms of what is really driving resource use, we need to conclude that actually it's the rise in income that drives resource consumption in most countries of the world. So if we start, for example, with India, China, Brazil, Germany, and USA, we see with rising income, there is quite a strong correlation with rising material per capita material consumption levels. So, and this is really maybe the core challenge for environmental sustainability, because these countries which are highly developed, high income, high human development index, and other positive indicators, this came and was achieved at the price of having huge environmental impacts and huge natural resource use. So the question is actually, will it be possible that these countries, which of course should move up here in terms of per capita consumption, economic consumption, is it possible to move into an area here which is not related to higher natural resource use? I think this is one of the key challenges also we as global humanity face, how we're going to manage the next decades. And I mentioned already at the beginning of my talk the issue of decoupling. So actually, is the economic growth decoupling from natural resource use? Here I start with a picture of the global economy again. We see here the red line is the development of global GDP. We see with a slight decrease here around the economic crisis, a steadily upward trend in GDP. The green line we've already seen before. This is the growing line of natural resource consumption, which means if we compare these two lines, that in the 1980s and 1990s, actually the global economy was improving in relative terms. So material intensity in these two decades was actually decreasing. Less and less materials, less and less natural resources were required to produce 1 unit of global GDP. However, we've seen and discussed the rising trends here before. With this highly and rapidly growing rates of natural resource, material intensity actually go up again. So this means that at the moment we don't face any decoupling on the global level, not even a relative decoupling, and not to say anything about the absolute decoupling, about absolute reduction, which would be required to really bring the world economy on a sustainable path. Finally, just very rapidly, we did some rough scenario calculations, assuming what would, or trying to estimate what would happen if the global economy and the GDP, the material consumption per capita levels would increase in developing countries, in emerging economies, towards the level of currently in the OECD countries. And if we calculate this, then we see that global material extraction and consumption would significantly further rise in the future, maybe leveling off at some 180 billion tons of resources annually, which would be more than a doubling of the current consumption levels. And this, of course, would bring about significant environmental challenges. For example, the overburden related to mining would increase. CO2 emissions from our energy use would increase significantly. Cement production would increase significantly the share to the CO2 emissions. Water requirements would increase. So this is definitely a scenario that's very challenging and critical from an environmental sustainability perspective. And then we calculated, okay, if we want to bring the world towards a path of absolute reduction, what is actually required? And we calculated some of the scenarios. For example, what would happen if the world economy improves resource efficiency by a factor 2? And we see, given different population scenarios, even a doubling of resource efficiency would not halt the current trends. Global material consumption would further increase. So what is actually needed in the long term is a much more ambitious target, something maybe like a factor 5 reduction until 2050. Only under such ambitious target, really the current trends will be able to reverse and come down in the future. Yeah, some conclusions. First, it must clearly be stated, and we can show this with our data, that current trends are alarming in many regards. So we have, if we look at the global level, rapidly growing levels of resource use. I've shown this for materials, but it's the same case for energy, it's the same case for water. Increasing pressures on land. So across many resource categories, the trends are very challenging. We see that here in the rich countries, we still have very high levels of resource consumption. We were not able to bring them down in the past few decades, while at the same time, some emerging and developing countries are rapidly increasing their consumption and absolute shares. And resource efficiency improvements took place to some extent, but they were not strong enough. They were overcompensated by economic growth in the past decades. So the final two slides, some ideas of, if we speak about a truly green economy and a transformation towards a green economy, what should be done? In industrialized countries, we think it's definitely necessary to think about strategies to achieve an absolute reduction or an absolute decoupling of natural resource from economic growth, because otherwise, if we don't free the environmental space, other world regions will not be able to grow physically. What is needed are clear policy targets, so clear targets, where do we want to be in terms of resource efficiency, but also in per capita consumption in 2030 and 2050. And of course, policy frameworks and instruments really targeted towards the resource issue. Resource taxes, for example, are one example. The fading out of environmentally harmful subsidies, for example, in the fossil fuel sector, still very common in many countries. Increasing research and innovation activities in dematerialized, resource-efficient products and services is key in these countries. On the other hand, developing countries and emerging economies, they will, to a large extent, require material growth in the future, because in many countries, the people still live on $1 or $2 a day, which is clearly unsustainable from a social perspective. So material growth will need to take place in these countries. In these countries, I would argue relative decoupling is the target. So if you need to grow, then try to grow as efficient as possible. And final point, I think the focus on infrastructure is a key issue for developing countries, because how the infrastructure is currently being set up, this will determine for the next decades how resource use and other environmental impacts will develop. Regarding buildings, energy system, transport system, these factors will determine finally how the global development of resource use will be shaped in the coming decades. Thank you very much.